Oh, what did you say? Is it recording? Yes. Like right now?
Yeah. So we were able to cut off that one problem, right? One that
Okay.
was bad, because it had an asymptote. It wasn't continuous from negative infinity to infinity, so it caused some problems for us. And then it ended up being like a double limit problem, and it was kind of fun stuff.
Yeah.
But yeah, it still ended up being indeterminate either way. So. But yeah, hopefully you were able to do the other two. Yes? I think both of them should have diverged, right?
Yeah.
Yeah. I fixed it by fourth block. Fourth block I gave them finally the right assignment.
By fourth block, so third block also had the same one as us?
Yeah.
We are
Oh, we are third block. Last semester, last year I had second block. I'm sorry.
It's okay. Alright, so here we go. We're going to talk about the second type of improper integrals finally. And hopefully we'll be done with improper integrals by tomorrow. So this is the second type of improper integral, and for the second type there's also three cases. Case 1 and 2 are very similar to each other. The third case is kind of like case 1 and case 2 put together.
Is it a new series?
Huh?
Is it a new series? Not P series, but a new series?
Oh no, like the P series.
I know how the brass
So
sounds.
we'll talk about something in relation to the P series today, because it's going to be kind of similar to it, and you can use the idea of the P series and what it does as it goes to infinity to find out what it does as it goes to 0.
Can we turn in the assignment from yesterday, Mr. Shek?
Yeah, you can turn it in. So the second type of improper integrals are integrals that involve infinite discontinuities.
What? A big hole?
So what do you think an infinite discontinuity is?
A hole?
It's a fancy word for what?
An asymptote. Pretty big.
Yeah, what kind of an asymptote?
Or vertical.
A vertical asymptote, right? So it's an infinite discontinuity. That discontinuity is not just at one point, but it's at
Every point?
an infinite amount of points, right? So it's a fancy word for
Infinite vertical vertical asymptote.
vertical asymptotes, right? So I'm going to work with my pre-cal teachers to make sure that they start using that word.
Vertical asymptotes?
Yeah, so they should start calling vertical asymptotes, not only vertical asymptotes, but infinite discontinuities. Doesn't mean it has an infinite number of discontinuities. It has an infinite discontinuity. Infinite discontinuity.
It's one.
One vertical asymptote, right? An infinite number of discontinuities would be like the step function, right? Where there's gaps in between each integer, right? So it's discontinuous at each of those gaps. Does that make sense? The greatest integer function. Remember that one? The one that looked like this?
Oh yeah.
Yeah?
But what equation gives you that?
Step function.
The greatest integer function, which is kind of like this. Kind of like a double bracket.
Okay.
Yeah? You don't see it very often. Won't be on the AP test. But that has an infinite number of discontinuities,
Yeah.
right?
Yes.
It's discontinuous here, and here, and here, and here, and here, and here, and here. Doesn't have an infinite discontinuity.
I was like,
Understand the difference?
yes.
Yes? Okay, beautiful. Fancy word for vertical asymptote. So the problems we're going to be working with today are not going to have an infinity and a bound. Okay? So you're going to have to be really careful when you're working with these guys. Okay? Because they're going to look like a regular definite integral that you've seen before. Okay? The only difference is now that that function that you're working with is going to have a what?
Vertical
It's going to have a vertical asymptote, and that vertical asymptote is going to fall within the bounds that we're working with. Sometimes it might be at one of the bounds, the top one, or it might be at the lower bound, or it might end up being where?
Both.
You know,
In between.
in between, okay? And we need to be careful how we attack those. So I'm gonna start off with writing all the mathematical notation and all that fun stuff. And
Yeah.
it might seem a little weird because we're gonna be using like a whole bunch of different letters. It's gonna be kind of annoying. But when we actually start doing an example, you're still gonna just stick to A and B because the bounds are gonna be numbers. And you're gonna replace those with an A or with a B. Cool?
Yes, sir.
Yes, no, maybe so? Alright, so let's check this out. Here's the first case.
XC001.
So if F
Yeah.
is continuous on closed interval A, open interval B. So what does that mean is happening at B?
B. Oh, B. It's a whole. No, or it cannot be reached.
So it's not continuous where?
At B.
At B, right? Okay. And we're gonna say that it has an infinite discontinuity at B. So that means it has a what at B?
Vertical asymptote.
Vertical asymptote at B. Okay, so if I have a vertical asymptote at B, that means the graph is going to go to some infinity at B, right? It's either going to go up to positive infinity or it's going to go down to negative infinity because it's never going to touch that vertical asymptote. Are you with me?
Oh, I'm with you. I'm with you.
Okay, now, so we got to write a limit to be able to work it out. But it's going to be a limit as we approach B. What's the only way to approach B?
The left
If I'm in this interval.
The left side.
I can only approach him from the left in this interval. What if I was approaching A, because that's where the vertical asymptote
From the
was?
right into the right.
And we'd have to do a limit from the right of A. Okay, so these problems are going to be improper because there's an infinite discontinuity either at one of the endpoints or somewhere in between. And to be able to handle those, you're going to have to approach that vertical asymptote from a given side.
What if it's somewhere in between? Where do you approach it from?
Both sides.
I got it.
Okay, if it's in between, you're gonna have to split it at that asymptote and do from here to here, approaching from the left, and then from here to here, approaching from the right. Okay, and that's the third case. Cool? So the integral from A to B of that function is going to, dx is gonna equal what? Where's the problem at? At B. Okay, so we're gonna have to do the limit as, this is gonna be a number on your problems, okay? So let's pick a letter. N? Okay. As n approaches B, from what side?
From the left.
From the left of the integral from where to where?
A to N.
A to n of
F of X.
f of x dx. That's how we would handle that particular guy.
And that's a negative?
That's a negative saying from the left of B.
Not saying it's a negative integral, right?
Not saying it's a negative integral, right? It's from the left of B. Put it a little bit too high there, I guess. Cool? Yes, no, maybe so? We won't have a problem when we actually work it out. We could use B here when we actually do it, because B is actually going to be a number. So if it's like a 5, you're going to say as B approaches 5 from the left. Okay? It's just right now for this notation that we have to use a random letter, because we're using a whole bunch of letters everywhere. Yes, no, maybe so? Alright, let's try the second case. So if F is continuous on open interval A to closed interval B and has an infinite discontinuity at where now?
At A.
At A, then the integral from A to B of f of x would have to be what?
The opposite of the top one.
Okay, so how would we do that one? The limit
of n
As n
goes to a.
goes to A, from what side can we approach A
The
from?
right, the right, the right.
Only from the right, ¿verdad? So think about it, A to B, how can I get to A? From the right side. How can I get to B? From the left side. Of the integral, from where to where?
A to B, A, no, n to B, n to B, n to B,
N to B
Contact.
of that function. We okay?
Yes.
Yes, no, maybe so?
Yes, yes, yes.
So these are both cases where the vertical asymptote or the infinite discontinuity occurred where?
At every point.
At one of the bounds, right? Or at an endpoint. So here we have vertical asymptotes at endpoints, right? So that's how you would handle those two different systems. Cool? So you're gonna see the integral, okay, and it's gonna look like a normal integral that you've worked with before, and you've never had to think of this before. All the integrals that we've done before with definite integrals, you just integrate and evaluate, right? You never even thought to check if it had a vertical asymptote somewhere in that interval, right? We just assumed that it worked out, right? But now, okay, you're gonna have to be extra, what?
Careful.
Extra careful, right? Or there's a word that starts with an L, with a V, and ends with a lent.
Extra bend.
Vigilant, right? Not violent.
Extra violent.
No, extra vigilant, right? And we're gonna have to make sure we're looking closely, okay? So when you do this assignment, you wanna get some tape, put it on your eyes, so they stay open, so you don't bleed. Ah, they hurt already.
I'm stable.
Don't do that, okay? But be extra vigilant, okay? In second block, I said it to them wrong. I said it starts with a V and ends with a gent. So they were right. Vigilant? So that was like the inside joke for the rest of the block. And then they're like, stop saying that! Like, I'm gonna write that on my papers now. You have to be vigilant.
Oh my god.
Can we use that? Can we have that joke here too?
Yeah.
So when I say vigilant, I mean vigilant?
But it's violent.
Yes? Or it could be violent, that could be our joke. Oh,
I'm pretty
So this guy, this is like a guy going on the elevator. Is he still farting on the elevator?
Yeah?
Yeah, he's still farting on the elevator, right? But we can't hear it, right?
It's silent.
The other one we could hear it because it had the infinity there, right? We knew he was improper from the beginning, right? This one's going in there and he's letting it out slowly, so we don't really know.
It's pretty like.
But we smell it. Ugh. It's totally improper, anyways. Alright, now let's look at the third case.
Case 3.
So the third case is the one that we said earlier, right? We have an asymptote at an endpoint, or we could have an asymptote where?
On the same,
In the
on
middle.
A and B.
Somewhere in between A and B, right? It doesn't have to be in the middle, but it could be in between here, right? Cool?
Yes.
So if F is continuous from A to B,
What if F is continuous?
except at
C.
some C in A to B,
Oh, the rhyme.
okay? So why did I put open parentheses here?
Because it's the,
Because C cannot be A or B, right? It has to be in between. That's what that's saying. Cool? And we have to say this because of an
interval E.
infinite
Discontinuity.
discontinuity, because it could be discontinuous due to a what?
Whole.
A hole or a what?
Horizontal asymptote. No, that's.
So there was 3 discontinuities.
Oh,
There was a hole,
Vertical asymptote. Vertical
Or
asymptote.
cut.
vertical asymptote,
Or a jump.
or a jump, right? Why is it that when it's a jump or a hole, there's no problem?
Because it could be
Because
fixed.
there's
It can
another
be
one
down.
next to it.
Well, let's think about it. Could I find the integral from one point to the hole and then from the hole to the other point?
No.
No?
Oh, wait. Yes, you can.
So could I find the area from here to here?
Yeah.
Right? And then from here to here, and add it up? Yeah, so there's no problem there, right? Gonna be fine there. Same thing if I had a jump, right?
Jump.
I can find the area from there to there, and then it jumps over here, and I can find the area to here, right? It would still be cool. The problem is when we have the asymptote, right? Because that graph's gonna go to some infinity, and we don't know if it's going to that infinity fast enough, right? To where we can figure out that amount of space between them. Does that make sense?
Yeah.
Sort of, kind of? So then, the integral from a to b of f of x dx is gonna equal what? How are we gonna do this?
So it's going to equal the limits?
Let's not do the limit,
Wait.
let's just do the two integrals.
Okay.
From A to C.
Oh.
So the integral from a to c, okay, plus
The integral from C to B.
c to b, right? It's kind of annoying, they're not in order.
Yeah.
But it'll work out when we do it the other way.
Of course.
Because these will be numbers, and then this will be whatever letter you want it to. Actually, they'll all be numbers. Then they'll become letters when we write it as a limit, right? And this will become what letter when we write it as a limit? B, because this will be a number, right? 5 to whatever the vertical asymptote is, which is B. And we gotta approach it from the what?
From the left. No, B, right. The right, right?
The
left.
right?
The left.
A is the lower
From the
left.
left, right? You can approach this guy from the left, right? Plus the limit as,
See it from the right?
this is gonna be